Okay, folks, ready to start up again? Tim is going to poke at Apple certificate tomfoolery.
All right, thank you guys for coming. I appreciate you guys coming out for this talk this afternoon. My name is Tim Medine. My background, I've got kind of a wide range of background. I was a control systems engineer for a while. Thank you. Software developer, network engineer, most recently a security consultant, penetration tester. Now I work for a firm, a company, Counterhack. We design challenges, CTFs, competitions for high school through professionals. We're actually working on a really cool project called Cyber City, where it's a hackable city where you can like derail the train and like kill the power and all sorts of fun stuff like that. Ed does some lovely presentations on some of that. At Counterhack, a good friend of mine and a coworker, Josh Wright. Unfortunately, Josh wasn't able to be here. He found out that this was on Valentine's Day weekend and wisely decided to not cancel his plans with his lovely wife and family and joined a bunch of smelly men at a hacker conference. So, that Josh Wright, the Josh Wright. So we had a couple of things that we went over. We researched here. Two pieces we're looking at. We got some iOS certificate. Sorry, if I like to wander like a lot. So if I go like completely out of range of this, someone like grab me and tackle me. And Atlas is here. I think he volunteered.
Grab that mic.
That's all right. So we have two pieces here. The first thing we're going to look at is using some of the ways that iOS incorrectly renders certificates. Play with that a little bit. And then also we're going to play with the root trust a little bit on the iOS devices and manipulating that remotely, kind of following the best practices according to Apple. So first, let's go for a little bit of background. When we see our certificates, this is going to be the normal user experience. This is my wife's phone. I do a lot of testing on my wife's phone because I don't want to mess up my phone. Pro tip, before you leave for a trip, fix her phone, okay? Just saying. So what happened here is I used EtterCap. I was redirecting traffic. I spoofed the DNS responses. I tried to send it to another site. Initially we're going to Shmoocon.org, the secure version of that. EtterCap said, hey, actually go over to this other site. I used a self-signed certificate. The normal user experience, we can see it on the left, says cannot verify server identity. And we get these three options. Ironically, the best choice here is for a user is to click cancel, right? Details is also an acceptable response. Apple doesn't want you to click continue, but because it's the only button they didn't highlight, it actually makes you want to click on it more. Right? That's so awesome. It's like, don't click here. Oh wait, it's the only one that's, oh yeah. So of course, what are most users going to do? They're going to click continue. If you click on details, you're going to see the certificate we've got over here. It says www.shmoo.org. Right? So we're like, what can we do with that? The correct answer is submit to Shmoocon for a talk on the subject. And then, so we get our fake certificate. A little background on checking certificates. There's 5 pieces of our certificate that you get checked when you get a certificate. Most people think of 4. There's one piece they commonly forget. The one we're probably most familiar with is it trusted? Is this certificate signed by something I trust? Or is it signed by something that's signed by something that's signed by something? Eventually, do I trust it? The Hong Kong post office or wherever. The date range, of course, that's a pretty common one too. Anybody ever go to their bank's website? It's like, sorry, your cert is invalid and it expired like yesterday. You're all lying, except for that guy. Banks happen all the time. Credit card companies happens all the time where they, oops, we forget to update our certificate, and they start scrambling to replace that. We also get revoked. If a certificate is compromised or superseded, we need to revoke the old certificate. Say, sorry, we signed you at one point, but we no longer trust you. You're no longer allowed to play in our house. We're going to kick you out of here. This is the one people kind of forget about, proper use. It also checks the proper use. Just because I've got a code signing certificate, it does not allow me to use that for web authentication, and of course, vice versa. We're also, in the case we've got most commonly too, is the name. We got to check the name. We got to check the name on the certificate, the CN, and in the case of web traffic, we're going to compare it to what? The domain to make sure it matches. So we played a little bit. Here's our creative certificate. We saw www.shmoocon.org. Right? So if I own some other domain.com, I can legitimately get this certificate. And we tried it with a whole bunch of providers, and they were more than happy to give us a certificate. Of course, I didn't give you my actual domain because I didn't want you to touch my actual domain. But so www.shmoocon.someotherdomain.com, and all we see is www.shmoocon.org. Cool, right? Of course, if we use it on our web server, we're going to go through those 5 checks, right? Is the certificate trusted? It is trusted. The date is completely valid. It has not been revoked. It is properly used for web authentication. Of course, the name's not going to match, right? Because we're using .someotherdomain.com. Shmoocon uses just shmoocon.org, and it's going to fail. You can see the user experience here, and Tom Hanks isn't so thrilled. You can see that our certificate is not trusted. So how can we get around the CN check? We got a few, okay, so with a web server, we've got a name we can check, right? We compare the domain name, we compare it to the CN. Do they match? We're good to go. They don't match, boom, we fail it. By the way, we got a drinking game built into this. The first one to identify the specific Tom on a slide makes everyone else around them drink. So have fun with that. So how are we going to avoid the CN check? Which way can we get around that? Well, we thought, okay, Wi-Fi. You got an enterprise a wireless in your environment. You want to connect to your network. You connect to the network. It doesn't do pre-shared key. We use each person has their unique username and password. Likely, it's some sort of Radius server on the back end. And inside that, the PEEP authentication, we're going to use some certificates. So we get the certificate back, and there's no name to verify it against. Unfortunately, this is where our research went a little south. Because there is no name to check it against, Apple will fail absolutely every single certificate because there's nothing to check it against. A self-signed certificate is just as good as a completely fake certificate because there's no name to check it against. If it fails any one of them, it always gives you not verified. So that was kind of actually a cool piece that we found out of this is there is no way to get that certificate to show up properly. There's no way to get that thing to show up nice and green and convince your users to click through. You just say, oh yeah, don't worry about it, just go. Winning for us, right? Well, ultimately, what does this mean? The certificates pretty much pissed us off a little bit. There was a lot of crying, tons of swear words, a little bit of uncomfortable snuggling, and some more crying. And then we finally decided, okay, well, how can we get rid of certificates completely? We decided, okay, we'll use PAP. Maybe we can use PAP. This is the clear text authentication mechanism. It doesn't use TLS. Unfortunately for us, fortunately for Apple, Apple did some good stuff here. It realizes, hey, last time that I talked to you, we used some sort of authentication thingy with some certificates. I don't see those anymore, so we're going to fail. The user's going to see an error message, unsupported EAP type. Of course, to a user, that means nothing, but it's not going to allow us to authenticate that way. So we got a little cranky. We're like, all right, so what else can we do? We need another way. Drink up here. You right here, right around Atlas. Nice. So we need another way to get around that. How else can we get some certificates on this device so we can effectively man in the middle or do other attacks against the phone? Using the certificate method that we were first looking at, we just realized that a self-signed cert is just effective. It's cheaper and it's easier. So realistically, that's probably going to be the way to go if you're going to be faking out the wireless, the Radius server. So what else we want to do is maybe we can install some certificates via malicious profile on the box. So that way we can man in the middle all the web traffic and other network traffic. Excuse me, I'm Shmoo flu patient 0. My bad to the few people up here in the front. So we can look at iOS configuration profiles. Anybody you guys play with these much? A couple of you guys? It's pretty cool stuff, actually. It's like XML files. You can do similar configuration like you can with, think, GPO in Windows. You can change all sorts of cool settings related to the phone. You can change security policies, restrictions, VPNs, Wi-Fi, network. It's not quite as full functional as like BlackBerry. BlackBerry has like 9,000 configuration settings. Apple has some really cool ones, and it has some really cool ones that we can really jack with. The fun part here is, well, how do we distribute this? Right? If we're just going to do it manually, if we don't have an MDM, how can we distribute these things? Well, we can plug it into a device, take our iPhone, jam it in the side of our laptop. That doesn't scale, right? You have to have everybody come by the laptop, plug in. That's not going to work. You can email it to them, winning, right? You've just told your users, click on a link in an email and start installing stuff. My personal favorite, SMS it. So we're going to send you a text, and you're going to inform your users, we will text you something, please clicky clicky, and keep following all the instructions and go through. In fact, And the document that, that Apple releases in their, what do they call it, their over-the-air delivery and configuration profile document, step one, they've got like this document's like this big old long document. But what do people do when they open up a big old long document? They go straight to the pictures. Page 9 is the first pretty picture in the diagram. Step 1 is user enters the URL of the profile service in Safari of an iPhone. Have you ever tried to convince get a user to type in a URL into their regular computer and get it correct? Users don't know the difference between a backslash and a forward slash, and they'll argue about it. So you're not gonna have them type it in. You're gonna say, all right, well, I'll just send it to you. What does it say in bold here? Or taps a URL sent in SMS. Oh, we're safe. SMS is secure. Right? So we can use a ton of different services to spoof that. Step 2 in the process, after they click the thing in the SMS, the user is presented a login page. Score. We've told people to click on something in the SMS, install it, and then randomly enter their credentials. Oh, this is all kinds of win. Step 3 is, how does it authenticate? HTTP basic auth. It's encrypted. Base 64. This is all. I can't read the password. Surely no one else can read it. So all sorts of fun stuff there. And then at the very end, the user is prompted to actually go through the install process. The user experience is going to look something like this. Look at a screen that looks like this. We've got our healthy foo bars, because everybody wants some good bars that are healthy made out of foo. Look at this screen, and they're going to click the install button. Now, when you create a profile, when you create a profile, you can distribute it a couple different ways. You can, of course, we can sign it, or we can unsign. We can leave it unsigned. If we sign it, we had that pesky problem with certificates. If we sign it with a cert that they don't trust, we'll see the red unsigned will say not trusted. The word trust is a word that users understand. I understand that what I trust and what I don't trust. The word unsigned means nothing to them. I don't know. That has nothing in their brain for the security context surrounding unsigned. It means absolutely nothing. So of course they're just going to click continue. And of course, because we can control the text there, the first line of text we write, this is authorized by Apple Incorporated, and we can put all sorts of other information in there. We give a whole bunch of text at the bottom to push off any sort of warnings so they go off the screen because no one's going to scroll down. So they click install there. It looks just like the App Store install. They get another screen where there's some words that they don't understand. The correct answer there is click next for most users, right? So they click next, and we pretty much have the, come on, next, click next. Ironically, my next button's not working. There we go. All right. Ironic, so they got the profile on their box. Now, on their iOS device. So now we've got this profile on our device. What are some of the nasty things we can do with those devices once we have our malicious profile installed? Talking about certificates here, real straight up easy one, install our own root CA. That's kind of cool, right? We can man in the middle of all the traffic without worrying. A little bit nastier is we can create our own Wi-Fi profile. The one I like to set up, I actually may or may not have tested this on my spouse, is you can create a couple of Wi-Fi profiles and set like ATT Wi-Fi. Pick a whole bunch of like really common ones. You're like, Tim, my phone already automatically connects to ATT Wi-Fi because that's what Apple wants it to do. Well, on top of that, you can also configure the proxy settings. Automatically connect to this and automatically use this proxy. Because we duct tape that together with the certificates, every time they walk near a Starbucks, it's automatically going to connect, it's automatically going to set the proxy, and it's going to use our certificates, and we can man in the middle of the entire traffic every time they're anywhere near a Starbucks. If they're working there all day, that kind of fun stuff. Of course, you can set this up with any named access point SSID that you want. Similar thing with VPN, just set up a VPN. Of course, every good VPN needs to proxy through my house, right? So I get to see all the fun traffic and manipulate it, steal credentials, and such. We got a couple of more eviler attacks, as we put it. The ones we showed in the previous slide, those are really useful for penetration testing, right? Those are the ones you're probably going to be able to do in a penetration test. Hey, I'm going to attack your users. I'm going to attack their phones. I want to see the data that's going back and forth. Maybe get access to one of your systems inside. Who knows what's going to happen. Now, if we want to be a complete bastard, we can do poor man's ransomware. When you get this onto the phone, there's a couple of different options we have for removal. You can restrict removal. You can say, well, the first option is, okay, you can remove it anytime you want. Well, that's no fun, right? The next option is you cannot remove it. You can restore the phone and remove it, wipe the drive, right? The next option is remove with passcode. So we create this big old long 20-character passcode, and they have to pay us money to get rid of it, kind of a thing, right? What can we do to make sure that they pay us to get rid of it? Well, we can disable Safari, right? If my iPhone didn't have Safari, you know what that's called? BlackBerry. That is the sole reason. I loved my BlackBerry. It was fantastic for email and contacts, but the browser sucked. If my phone didn't have Safari on it, oh my gosh, would it be useless, right? We can also disable the camera. Another fun one here is we can disable the iCloud backup. So if they let this run long enough, they're going to stop backing stuff up, and they'll be a little bit more afraid about restoring from backup because they may not have been backing up. We can also install a custom web clip. Just because when this happens, like, okay, well, something bad happened to my phone, I don't know what's going on. You throw in this little icon on their phone. They open that up, it goes to your site, and you say, yeah, you've been owned for $35. We'd be more than happy to give you the passcode to remove this thing, and we can have tons of fun there. Of course, to remove this, how can we remove it? Backups. Do users do backups? No. The correct answer is no. Users don't do backups, especially in an enterprise environment, right? My IT people do backups for me, right? So it's going to be a little bit more effective in that case. So what can we do to protect against that? Well, don't click on stuff. I mean, that'd be like most of the talks here, like one sentence, like don't click on stuff. And on top of that, don't tell your users to click on stuff, for the love of God. Don't tell them to do that. You work in IT, right? How many of the problems exist because users click on stuff? We should not tell them to randomly click on text messages, even though they're secure, right? And users, because they have their phone, they don't think of it the same way as they do their computer. They treat it differently. It's like, oh, okay, this thing, there's nothing that can infect my phone. Yeah, we can. There's a good feature in iOS 6. In iOS 6, there's some MDM features. We don't get the same this option in the iPhone configuration tool. We get it through the MDM tools. We can actually say, do not allow any new profiles to be installed. And that's an effective way to prevent against these profiles from being installed and messing up your phone. All right, so conclusion. Sorry, I'm a little sick, so I can't stand up here too long without completely hacking up my lung. The certificate stuff, it was pretty cool. I'm hoping somebody else can take that rendering issue and maybe find some more issues on some other platforms, take it a little bit further. It proved to not be quite as fruitful as we were hoping. The malicious profile stuff, that's fun, right? Again, remove it from your spouse's phone before you go on a trip, especially when you're on the airplane. It's like 2 hours and no phone calls. So her phone did work because I got plenty of voicemails, so it wasn't that bad. So other than that, that's about it. Anybody have any questions I can answer here? I'll get some water. No, Moxie did all that, so we just left it. I thought he did. Maybe I'm wrong. Did you guys hear his question? He was asking about the SSL stuff, if we'd done what he had with, Moxie had done with SSL strip, had done on iPhones. I believe somebody had done that research already, that's why we skipped that piece.
I've seen this like attacking wireless enterprise iPhones, but my question really is with BlackBerries. I was able to still get access to BlackBerries. I don't know, maybe there was some updated software for that or on that.
So he's asking about the BlackBerries and the evil twin working on BlackBerries. I don't know. I don't have a BlackBerry anymore, thank God. All right, any more questions? Excuse me. None? All right, well, thank you guys very much. Have a good rest of the weekend.